Solving systems of equations by elimination. Okay, so this is the third day worth of doing it. It means that we've already been doing it for 2. And there's a few things that we really need to look for as far as the elimination goes. Okay, first thing that we're going to look for is we're going to look for things in the form ax plus by equals c. Okay, this is a clear indicator that we should be doing elimination on that problem. Okay, second thing that we should be looking for, okay, whenever we actually start, we're going to be looking for 0 pairs. Okay, 0 pairs. Things that are 0 pairs are things like 3 and negative 3. 3x, negative 3x, negative 5y, and 5y. Things that when added together are going to equal 0. Okay, now coming over here to problem number 1. Okay, on problem number 1, okay, the 0 pair literally jumps out at you and, tells you, hey, cancel me. So we're going to go ahead and we're going to add these 2 rows together. As you probably guessed, we're going to use the 5b's as our 0 pair. We eliminate that, and what we're left with is 9a equals 45. We divide each side by 9, and we have a equals 5. Okay, now we can go ahead and take this a that we just came up with and plug it back in at the top. Okay, and that's going to be 5 times 5 plus 5b equals 20. We're going to take 25 plus 5b equal 20 and subtract 25 from both sides, and we're left with 5b equals negative 5. Divide each side by 5, and we're left with b equaling negative 1. Okay, so b equals negative 1. Now, usually we're used to having x and y, but we're going to put them into our ordered pair in alpha order. So a, b, 5, and negative 1. Alright, negative 2. As you can see, negative 2 does not just have something that jumps out and screams, hey, eliminate me. But what we can do is make our own 0 pair. Okay, the first part, that's top row, is 3x plus 6y equals negative 6. The bottom part is 5x minus 2y equals 14. Okay, the best thing to do is to look for something that when multiplied will give us a 0 pair. So the easiest thing to do would be to multiply this bottom row by 3. Okay, and when we do that, that is going to give us 3x plus 6y equals negative 6, and then we've got 15x minus 6y equals 42. Right? Now, when we go to add these 2 rows together, what's going to happen is we're going to get 18x with a canceling 6y's, and then negative 6 and 42 are going to give us 36. Okay, we divide each side by 18, and x equals 2. Alright, so we take this 2 that we just came up with, and we're going to take it and plug it in back at the top. okay? And that's going to be 3 times 2 plus 6y equals negative 6. We got 6 plus 6y. So we're going to subtract 6 from both sides, and we've got 6y equals negative 12. Okay, and at that point we can come up with y equaling negative 2 pretty quickly. We just divide each side by 6. Right? On to number 3. All right, so on number 3, again, it's very similar to number 2 in the fact that we don't have a number just screaming at us that says, hey, you can cancel me. So what we have to do is we have to go ahead and make our own zero pair. In this case, I'm going to multiply the bottom row by negative 2. All right, and that's going to give me 2x plus 2y equals 4, and negative 2x minus 2y equals negative 18. Okay? Now, something rather peculiar happens whenever we see this. Whenever we add the top row and the bottom row, we're going to have 0 plus 0 equals 4 plus minus 18 is going to be negative 14. Okay, and what we come out with at the bottom here is going to be 0 equals negative 14. Okay, now yesterday we talked about what happens if we have the same thing on both sides as far as numerical. Now, what happens if it's different? Well, when it's different, okay, we are going to have no solution. Okay, no solution. Okay, there is no number that will work for both of those equations. No set of numbers. All right, number 4. Okay, number 4 again is kind of peculiar in the fact that you can't just see something that is going to cancel. Now, what do you think would be the easiest thing to do? What can we multiply by to make this work? Now, if you notice, there's nothing that we can multiply the top by to get a number on the bottom, and there's nothing that we can multiply the bottom by to get something on the top. So what that tells me is that we're going to have to actually multiply both of them. Okay? Now, what could we multiply by to get a common multiple or a common number? What I see is on the top, I could multiply the top by 2 and multiply the bottom by 3. Okay? And whenever I do that, I'm going to have 22x plus 6y equals negative 42. And then I'm going to have 21x minus 6y equals positive 42. Okay, and just like before, I'm going to add these two problems together, or these two equations. Now, 22x plus 21x is going to give me 42x. Okay, and just like before, our y's are going to cancel, and we're going to be left with negative 42 plus positive 42, which is going to be 0. Okay, we divide each side of this by 42, and all things when you divide 0 by anything, the correct answer is 0. Okay, so we know that x on this one is going to be 0. All right, so we take our 0 and we're going to plug it back in right up here. Okay, so if we go ahead and we plug that in, we're going to have 7. We're going to have 7 times 0 minus 2 times y equals 14. All right, so the 7 times 0 kind of goes away, and we're going to have to solve for y. So we got division by -2, and we got y equals -7. And there we go. All right, now, number 5. Remember how back up here I said that we're looking for things to be in standard form? Okay, we're looking for things to be in this form right here. Okay, the ax plus by equals c. As you can see, number 5 is not lined up for us. Number 5 is not ready. Okay, so in order to do this, we need to go ahead and move our y's over. Okay, we can go and move that over and move that over. Okay, so we're going to have 3x plus 5y equals 30. And then we're going to have 5x plus 8y equals 49. Okay, make sure that you, whenever you move it over, you change that sign. Okay, now, just like on number number 4, okay, we don't have anything that just stands out and screams, hey, I can cancel. Okay, so what we're going to have to do is we're going to have to come up with our own 0 pair here. Now, in order to do this, we are going to multiply the top and bottom by some number to get a common multiple. Okay, in this case, I would say to use 5 on the top and -3 on the bottom. All right, now whenever I do this, I wind up with 15x plus 25y, and that equals 150. And then I've got -15x minus 24y equals -147. All right, now, as you all know, okay, when we add these, those 15s are going to cancel. We got 25 plus -24, which is going to be a single y. And then 150 plus -147 is going to be 3. All right, so we know that y is going to be 3. Okay, and just like before, we're going to go ahead and we're going to take our 3 and plug it back into the top. Okay, so what we're going to have is 3x. We're going to have 3x equals -5 times y, which is going to be 3, plus 30, which in turn is going to go 3x equals -15 plus 30, and that's going to be 3x equals 15. Divide each side by 3, and x equals 5. Okay, so our final coordinate is going to be 5, 3. Okay, now, it's going to be a very similar procedure on number 6, except we don't have to rearrange anything. All right, so let's go ahead and give that a shot. All right, on number 6, okay, number 6, okay, what do you think we could multiply by to get a 0 pair? What would be the easiest thing? Let's try to keep the numbers small. Things that I see. Okay, I see 7 and -2. Okay, and whenever I go to do this, that's going to wind up being 42 plus 14y equals 28. And then I'm going to have -20x minus 14y, which is going to equal 16. All right? Now, let's see what cancels. Okay, we can obviously see that the 14's cancel, 14y's. Okay, what we're going to be left with, though, is 22x equaling 44, and then we're going to divide by 22 on both sides, and x equals 2. So we know that's there. So now we take this x, we're going to plug it back in at the top. All right, like I said, I like dealing with smaller numbers, so we're going to go ahead and go 6. Let's use a different number, a different color. So we're going to have 6 times 2 plus 2y equals 4. That's going to give me 12 plus 2y equals 4. We subtract 12 from both sides. We got 2y equals -8. We divide each side by 2. And y equals -4. Alright, now, just to double check this, okay, if we go 2 plugged into the top one, okay, that'd be 6. Okay, that's going to be 6 times 2 plus 2 times -4. Okay, that's going to be 12 and -8. 12 minus 8 is 8, or 4. Okay, now try the other one. Make sure that that one works as well. We're going to go 10 times 2 plus 7 times -4. Okay, that's 20, and that's -28. Okay, when we combine those, that is -8, checked and checked. Like I said, you don't have to do a formal proving of this, you just have to make sure that it's right. Okay, so there's that. Alright, now, on the second page, as you can see, it's a lot of word problems. It's just 4. It's not that bad. So, starting off, we have Brianna's family who spent $134 on 2 adult tickets and 3 youth tickets at an amusement park. Max's family spent $146 on 3 adult tickets and 2 youth tickets. What is the price of a youth ticket? Alright, so Brianna's family spent $134. So we can go, the way that I see it, it's going to be 2a plus 3y equaling 134. Okay, with a meaning adult and y meaning youth. Okay, so what we're going to do is we've got 2a plus 3y equaling 134, and then Max's family, it's going to be 3a plus 2y equaling 146. All right, now, just like before, we don't have anything that jumps out and screams to us, hey, we can cancel. Okay, so what we have to do is we have to go ahead and find something to cancel, make something cancel. All right, I'm going to multiply the bottom one by -2. I'm going to multiply the top one by 3. Right, and when I do this, I'm going to wind up with 6a plus 9y equals 402. All right, and then when we multiply by -2, we're going to have -6a minus 4y equals -146. Oh, no, -292, my fault. Okay, now, we're going to go ahead and combine these two rows. Okay, and as we know, those are going to cancel. Right, and we got 9 minus 4, which is going to be 5y. And then 402 minus 292 is going to give me 110. We divide each side by $5, and that's y equals 22. All right, so a youth ticket cost $22. All right, now we've still got to go back and find the adult ticket and how much it costs. So we take our 22 and we're going to plug it back into our original equation. So we're going to go 3a plus 2 times 22 equals 146. All right, and then we're going to have 3a plus 44 equals 146. We subtract 44 from both sides. That should be a 6, not a 4. Say one thing, write another. All right, so we got 3a equals 102. We're going to divide each side by 3. And we have a equaling 34. Okay, so it's $34 for an adult ticket to the amusement park. Okay, it's not too bad. Okay, just make sure that you're putting everything with what it goes with, if that makes sense. All right, so on number 8, all right, Kurt has some coins. Okay, he has 23 of them. Some quarters and some dimes. Their value is $3.50. How many of each coin does he have? All right, so we know that the number of quarters and dimes must total 23. Okay, so we've got Q for quarters. Okay, and then we're going to have D for dimes. Okay, so we take our quarters and dimes, and when we add those together, that should be 23. All right, now, the value of a quarter, as we all know, is 0.25. Okay, so we got 0.25 Q plus, and then the value of a dime is going to be 0.1 D equals $3.50. All right. Now, again, this is just like those ones that we've been working on so far, where we don't have something that jumps out and screams, hey, cancel me. Okay? What we have to do instead is we have to multiply by something, some kind of a factor to make a zero pair appear. So what we're going to have to do is actually multiply this bottom row. The best thing I can do is multiply this bottom row by -4. Okay, and when we do that, we wind up with Q plus D still on the top row. All right. And then on the bottom, we have negative Q minus 0.4D equals negative 14. Okay, and when we go ahead and we crunch this all together, okay, we're going to go ahead and add these two rows. Okay, the Q's cancel. Okay, and we got 0.6D equaling 9. Okay, and then we divide by 0.6, and then we got D equals 15. All right, that's not 15, that's definitely a 1. Okay, 15. So now I'm going to take that 15 and plug it back into the original equation, okay? So we're going to go Q plus 15 equals 23. This is one of those original equations, okay? Okay, all I did was I plugged in that 15. So I minus 15 from both sides, and I'm left with Q equaling 8. All right? It's not that bad. Okay, so moving right along here. Okay, last month Stephanie spent $57 on 4 allergy shots and 1 office visit. All right, so we got 57 equaling 4A plus 1D. All right, where, let's see, I would say that A stands for allergy shots. Okay, and D stands for office visits. Okay, and you're probably wondering why I'm not using O. Primary reason is because my O's sometimes look like zeros, and I don't want to get confused, so avoid the confusion. So we got 4A plus 1D equals 57. We know that. Okay, this month she spent $9 after 1 doctor visit, so we know that we're going to have 1 doctor visit and try to keep things lined up. And a refund of 2 allergy shots, okay? Refund. Okay, 2 allergy shots. So whenever we get a refund, that means that we're getting money back that we would have spent normally. So we're actually going to subtract 2A. Okay, and that winds up equaling $9. Okay, so we have 4A plus 1D, and we got 2A plus 1D equals 9. Okay, now what I would do in order to get something that's going to cancel, I would multiply the whole thing, kit and caboodle, by -1. I would multiply this one by -1. So when I do that, I wind up with 4A plus 1D equals 57. I didn't have to change anything there. But what I wind up with is 2A minus D, 1D, equals -9. Right? Now when I go to combine these, I'm going to have 6A. Okay? And we know that our D is going to cancel there, and then 57 minus 9 is going to be 48. Okay, we divide each side by 6, and we have A equaling 8. Okay, so we've got $8 for an allergy shot. Now we got to take this 8 and plug it back in up here. Okay, so we got negative 2 times 8 plus D equals 9. That's definitely supposed to be a 9. Equals 9. Okay, so we got negative 16 plus D equals 9. We add 16 to both sides, and we've got D equals 25. Okay, so the number of doctors or office visits, or the amount of an office visit, is $25. Allergy shots are $8. Okay, last question. Okay. Okay, so Kate bought 3 used CDs and 2 used DVDs at a bookstore. Okay, so let's just go ahead and get our stuff labeled here. Okay, we're going to go C is going to be CDs, and D is going to be DVDs. Okay, now what we're going to do is we're going to be setting up each one of these costs. Okay, so we're going to go 3 C plus 2 D, right? And that's how much Kate bought. Her friend Joel bought 1 CD and 5 DVDs. Okay, we don't know how much they spent total yet. We're about to find that out. So Kate spent $23.95. And Joel spent $33.94. All right? Now, there's nothing that screams, hey, I can cancel. So we have to make our own canceling term. Now, I'd suggest to multiply this bottom row by -3. Right? Now, when we do that, we wind up with 3C plus 2D equals $23.95. Right? And then we got negative 3C minus 15D equals negative 101.82. All right. So here's what happens, okay? The CDs cancel, and what we're left with is negative 13D equaling negative 77.87. We divide each side by negative 13, and D equals 5.99. Because don't forget, when you divide a negative by a negative and a negative, we wind up with a positive. All right, so the DVDs cost $5.99 each. $5.99. All right, so we got $5.99 for each DVD. So we have to go back, plug in, and figure out how much the CDs cost. Now, easiest route would probably be this one, since we already have the C's isolated. Now, let's see. We're going to go C plus 5 times $5.99 equals $33.94. All right, so let's see. C plus $29.99, or $29.95, my fault. $29.95 equals $33.94, and then we subtract the $29.95 from both sides, and I wind up with C equaling $3.99. Okay, so the CDs cost $3.99 a piece. And that's it.